Class example 2.23 gives us another opportunity to walk through synthetic division when the binomial has a lead coefficient other than 1. Here, we're given another cubic expression dividing by 3x plus 1. We start by writing the coefficients of our polynomial. Here we have a 9 for x cubed, an 18 for x squared, a negative 1 for x, and a positive 2 as our constant term. You'll notice that I named all the degrees for each term because I want to make sure that we're not missing one. Again, if we had 9x4 as our first term and then proceeded to 18x squared, we would need to include a coefficient of 0 for the missing x cubed term. Because our divisor is 3x plus 1, we can solve to determine that that would be a value of negative 1/3 that would generate a 0 there. To do that, simply write 3x plus 1 equals 0 and solve for x. So we're going to put our divisor value as negative 1/3. We drop the 9 and multiply it by negative 1/3. Remember, when multiplying an integer by a fraction, you simply multiply the integer by the numerator of the fraction and then divide by the denominator. So 1/3 of 9 was like saying 1 times 9 divided by 3. So negative 1/3 times 9 would give us negative 3. We add to 18 to give 15. Negative 1/3 of 15 is negative 5, which adds with negative 1 to make negative 6, which multiplies to make positive 2, and adds up to a remainder of 4. Our quotient is therefore 9x squared plus 15x minus 6 with a remainder of 4. In our division statement, we write the polynomial is equal to the quotient times the divisor plus the remainder. And now we draw out the common factor from our quotient to put it back into the divisor's brackets. With this, we end up with our divisor looking like it did in the original question, and we have a finalized division statement. One more time, I'll mention that dividing by a binomial with a lead coefficient other than 1 is beyond the scope of Math 30-1.